Show what you can do. Chapter 3, it's a practice test done by me, Mr. B. Try to master all the standards that you can see. You can do it. You just need some mental elbow grease.
What up? It's Mr. Barberia. Coming in real grumpy this morning. It's not your fault. Just figured I'd let you know. All right, so let's go ahead and we're doing the Chapter 3 practice. Show what you can do. You got 5 standards on this one. So let's go ahead and roll through them. So the first one here says rewrite the following expressions as addition expressions and then simplify. Remember that we know if we want to change subtraction to addition, we have to change the sign on the number that we are subtracting. So starting with this, I'll do my work over here. If I start with -8, the first number does not change. He's still -8. We can't do anything about that. We start at -8. If we were on a number line, we would start at -8 no matter what. Now, instead of taking away 3 negatives, I'm going to think of this as adding, and then I have to change the -3 to a +3. So taking away 3 negatives is the same as adding 3. And if you think back to your algebra tiles, remember taking away 3 negatives, we would subtract them from 0 pairs normally, if we ignore the -8 for a second, and it leaves behind 3 positives. That's why it's the same thing here. So now that I have -8 plus 3, I'd have 3 sets of 0 pairs, and that would leave me with -5. So -5 is my first answer here. Next one, -11. This is one that gets a lot of students. They think this is 0 because it looks like 11 minus 11. But if we rewrite this, -11 plus, and now originally we were subtracting a +11, so now we're going to add a -11. And that actually really helps me to see that it's not going to be 0 here because I'm actually adding 2 of the same thing. So when I add that up, it's going to give me -22. Moving down to the next one, 4 minus 2. The parentheses there aren't really doing anything. They're just hanging out around the 2. So don't let those fool you. So I'm going to rewrite this as 4. I'm going to change it to plus. This was a +2 before, so now it's going to be a -2. So now I have 4 positives, 2 negatives. That would make 2 sets of 0 pairs, and I would be left with 2. So it's going to be 2. It's also, I mean, this is 4 minus 2, by the way, so you know what this is, right? So sometimes we have to remember to use, not common sense. I don't like the phrase common sense. You have to use the knowledge that you already have. You don't want to get so caught up in a new idea that you forget to think about the things that you already know. And this one we're going to have to do it twice. So I'm going to tackle this in 2 chunks here. So -8's still hanging out. Remember that first number does not change. I'm going to change this subtraction to addition, which means I have to change my -1 to a +1. Now I'll cover that up. So look here. Now I was subtracting +3. So I'm going to change that to addition, and my +3 becomes a -3. Okay, now I have how many negatives here? I have 8 negatives and 3 more negatives, so that's 11 negatives plus 1. And then I have 1 0 pair now, so that would actually leave me with -10. Awesome. Okay, cool. So that's standard 1. Moving down to standard 2. All right, I have 6. These are just simplified, so any way we want to do this. So 6 minus 91. We can go whatever way we want. I think this one actually helps to see it as 6 plus -91. I'm just doing the same thing we did in the first one. How many 0 pairs would these make? So the 6 positives would cancel out with 6 of the negatives. What I see a lot of students do here, so I'll go ahead and show this to you, is they think of this as 91 minus 6. And they do that because you have 91 negatives, and they're canceling out with 6 of the positives. Now here's where you have to be careful. When we subtract these, we borrow that from the 9, that's 11. 11 minus 6 is 5. 8 just comes down, so it's 85. Remember, this isn't positive 85 because we had 91 negatives and we added 6 positives. So this right here was really 91 negatives adding 6 positives. So that's a -85. Make sure you don't lose track of what sign, positive or negative, is on your number. All right, next one, B, just a classic addition problem. I think I'd probably just line this one up and add. So 289. I never know how to organize my work over here, so I apologize if it's kind of random. 9 plus 3 is going to be 12. Carry the 1. That's 9 plus 4 is 13. Carry the 1. And that's 3. So 332. That makes sense looking at those numbers. Here's a nice subtraction problem. I'd probably just subtract this the classic way because we got a bigger number in the front. So I'd go 65 minus 32. 5 minus 2 is just 3. 6 minus 3 is 3. So that's 33. And then 1 minus 12. I don't know which way I would go. I don't know what I would do if I were you guys. There's a lot of different ways we can go here. I would maybe go, let's do what we've been doing. So 1 plus negative 12. So I'm going to have one set of 0 pairs. That means that one of these negatives is going to cancel out with this one positive. And I'm going to be left with negative 11. I hope that's okay for me not to show the work on that one. I think you guys can see that. Hopefully my talking helped. All right, standard 3, which is split over 2 sides. Because, I don't know, formatting is hard. Okay, so show how to write each of the following as a numerical expression, then find the value of the expression. All right, 4 added to 6 groups of 11 minus 3. So the 4 added is just going to be 4 plus. You can do it at the front or the back. It doesn't really matter. 6 groups means multiply by 6. So 6 groups of, and then my 11 minus 3 just goes right there. Oh, it does say find the value of the expression. Okay, now, order of operations. Look at my terms. This would be a good time for me to have another pen around. Let me see if this blue pen's going to work. I would circle this term right here. Oh, it seems that this pen is not going to work. I can just put an indentation on my paper. All right, we'll just stick with black. So here's one term. Here's your other term. And then you even have terms inside of the parentheses, but I don't usually circle those ones. So you go inside the parentheses first. 11 minus 3 is 8. So I'm going to rewrite this as 4 plus 6 times 8. Now, I got to continue to simplify this term here. So 6 times 8 is 48 plus 4. And then 4 plus 48 is 52. All right, I'm moving over to the back side now. Ooh, and everything kind of leaked through my page here. So why don't we just use a new one? All right. So same instruction here. Sorry that it's kind of hidden at the top. So 3 groups of 7 reduced by 4 groups of 2. We're going to start with 3 groups of 7. Groups is multiplication. So 3, I'll do it up here. Groups of 7. Reduced means subtraction. So reduced by 4 groups of 2 is 4 times 2. Again, if I circle my terms, this is a term right here, and this is a term right here. So 3 times 7 is 21. Minus 4 times 2 is 8. And 21 minus 8, wow, that was harder for me to think of than I thought it would be, is going to be 13. That was strangely hard for me in that moment. Okay, so there's 13. So I'm going to pick up here again at A. Now, 5 groups of negative 8, 5 times negative 8. So that's going to be 5 times 8 is 40. But I have 5 groups of 8 negatives, so my answer is going to be a negative 40. You could also remember that a positive times a negative is always a negative. Next one, part B. It's negative 3 times negative 6. So 3 times 6 is 18. A negative times a negative is a positive, so it's going to be positive 18. Remember when we did our tiles, we thought of this as taking away 3 groups of negative 6, and we left behind 18 when we did that from 0 pairs. Here we got to multiply 3 times, so let's take it in chunks. I'll do it over here. So 9 times 2 is 18. And it's a positive 18 because it's a negative times a negative. Now when we bring in this other negative here, this negative 7, our answer is going to be negative. So 7 times 18, 7 times 8 is 56. I'm going to put it over here so I don't forget. 7 times 1 is 70. And then 70 plus 56 is going to be 126. I think that makes sense. Hopefully it does. I'll check it later to make sure I did it right. All right. If it's in this video, you know I did it right. Okay. Now, 15 divided by -3. We can divide it if you want. So put the 15 inside, put the 3 on the outside. It really doesn't help because 3 goes into 15 5 times, so we're just done. And same rules as multiplication apply. So because it's a positive divided by a negative, my answer is going to be a negative. Letter E, 36 divided by 6. 6 times 6 is 36. So it's just going to be 6. And it's a negative divided by a negative, so it'll be a positive answer. Again, same rules. If you have a negative times a negative, it's a positive. A negative divided by a negative, it's also a positive. And then finally, 54 divided by 9. 9 times 6 is 54. So it's going to be 6. And it's negative because it's a negative divided by a positive. All right, moving down. Can't catch a break. This iPad keeps getting full of memory. All right, so on to 4. We're saying what property is each one of these? Remember the associative property. We only have 2 right now. Associative property, commutative property. Associative property says when you're adding or multiplying, the grouping symbols don't matter. So if I have A plus B in parentheses and then I add C, it's the same as if I do A plus and in parentheses B plus C. Which is connected to the commutative property because the commutative property says it doesn't matter what order you add things in. So, or multiply, add or multiply. So A plus B plus C is the same as, let's say, C plus A plus B. These are just numbers here. We can think of this as 2 plus 3 plus 4 is the same as 4 plus 2 plus 3. So looking here at the first one, we got parentheses, so there's a good chance it's going to be associative. So 4 plus 5 plus 4 is the same as 4 plus 5 plus 4. So you can see all that changes, the parentheses jumped around this one. So that would be the associative property. This next one here, 2 plus 4 plus 7 is the same as 2 plus 7 plus 4. That's very similar to what I wrote here for commutative. That's the commutative property. We just changed the order that we're adding these numbers up in. Again, 4 plus 8 plus 6, or 6 plus 4 plus 8. Notice the grouping symbols didn't change in this one. I kind of tried to trick you here. So the 4 plus 8 moved. The order changed. The grouping symbols didn't change. So in this case, it's another example of commutative. You got to be careful on these. Just because it has parentheses, don't assume it's going to be associative. Because I will try to trick you on that just to make sure you actually understand it. And then 3 plus 5 plus 7, 5 plus 7 is in parentheses. Now the 3 plus 7 is in parentheses. But notice the order of the numbers also changed. So you could kind of make an argument that it's either one. I think I would still go with associative though. I guess it's kind of a little bit of both. I'd probably say associative / commutative. I think that was actually my intent when I wrote it, was to create one that kind of had both. Because the 5 is now moving to the back. And the grouping symbols. But you can see they're very related, right? These two properties are very similar. All right, finally, the last section. Feels like it's taken me a half hour to do this because of all the times my computer's died. Or my iPad's running out of memory, I mean. All right, we're dividing fractions. We showed you 2 methods in class, or at least I focused on 2 methods. The number line one is a little more complicated, or it's not super helpful. So there was the common denominator method, and there was the supergiant 1 method. And in any case, there's keep, change, flip, which is really part of the supergiant 1 method. I'm going to show you them in the full method here. Okay, so I was doing this problem right here, dividing. I changed these to improper fractions. So now that they're improper fractions, I'm going to go ahead and use the common denominator method for this one. So I need to change these both to a common denominator. Common denominator for 5 and 8 is 40. So 13 over 5, I'd multiply those both by 8. 8 times 13 is 80 plus 24, so it's 104 over 40. Divided by, and 7 over 8. So 8 times 5 is going to be 40. So then I have to do 7 times 5, so that's 35. And now the beauty of this method is once I've got these, I can just take these two, and it's 104 divided by 35. So 104 divided by 35. The next one here, 4/9 divided by 4 1/3. Again, I'm going to change 4 1/3, so it's going to become 4/9 divided by 3 times 4 is 12, plus 1 is 13 over 3. It's funny that I got another 13 in there. Okay, this is also good for the common denominator method. So I would probably do that here again. I'd probably go
4/9 would stay the same. I'm going to make 13 thirds into ninths. So 4/9, multiply these by 3/3. So that'd be 39/9. And again, now it's going to be 4/39. So I didn't really show you the super giant 1 there. I'll come back at the end. Actually, no, you know what? Let's do it right now. I'm going to go back up to this one. I'm going to show you with a super giant 1. Because I would regret not showing you that method at least once. So I'm going to start here. So 13/5 divided by 7/8. So 13/5 divided by 7/8. And you all know that you can divide fractions using keep, change, flip. So you can go 13/5, change division to multiplication, and you use the reciprocal over here. So 5 times 7 is 35. 35. 8 times 13 is still 104. At least I hope so. I'm doing that in my head. 8 times 10 is 80. 8 times 3 is 24. 8 plus 24. 80 plus 24 is 104. So you can see the answer there. Oh, gosh. You can see the answer there. But when I show it with a supergiant 1, remember we write 13/5 over 7/8. And then we multiply by a supergiant 1. That's the reciprocal of the denominator. So 8/7. 8/7. And then my 13/5 times 8/7 is found right here in the top. The denominator becomes 1 because any number times its reciprocal is 1. And the numerator is going to be that good old 104/35 again. So I hope that's okay. I just wanted to show that to you. Moving on here, we're down to the last one with decimals. 6.25 divided by 4.2. I'm going to write it as a fraction first. So 6.25 divided by 4.2. Remember with decimals, we're just going to multiply these each by, essentially a giant 1 to move the decimal over. You can even just count how many times you need to move it. So I would multiply these both by 100 because I need that top one to move twice to become a whole number. So after I do that, that'll be 625 on the top. And on the bottom, it's going to move twice still, so it's going to be 420. So now I have 625 divided by 420. I'm going to put the 625 inside the house, the 420 on the outside. All right, so we're at this point right now. This is going to be a crazy decimal, so all we're going to do for the sake of this video is we're just going to do a 2-point. We're going to go to 2 places. So we will find the decimal to 2 places, and then we're just going to stick with that. On your actual test, I won't give you one that's this hard. Or that it's not so much that it's hard, it just goes on for a long time. So 420 goes into 625 once. 1 times 420 is 420. I subtract. 5 minus 0 is 5. 2 minus 2 is 0. 6 minus 4 is 2. 420 does not go into 205, so I put a decimal point. I bring down a 0. 420 goes into 2,054 times, I believe, because 4 times 420 is 1680. And if I were to add one more 420, I would go over by 50. So I'm going to subtract these now. So 2,050 minus 1680. I'm going to go ahead and just kind of cheat. I got a calculator over here. Again, I won't give you this big a number on the actual test. So that's going to leave me with 370. 420 does not go into 370. We're going over a place value, so I get to bring down another 0 for free. Probably should draw that arrow. And then 3,700. 420 is going to go into that 8 times. Because 8 times 420 is 3,360. I subtract. And my remainder would be 340. And we're just going to stop there. It would keep going. I believe there's another 8 after this. I actually think here, I'll go ahead and use my calculator so you can see it. So 625 divided by 420 would be 1.488095. It's a pretty ugly one. So we'll just stop there. Again, on the actual test, I won't give you one that's that long, but I want you to at least know how to start dividing there. Okay, that was it. This was insanely stressful for me. It's not at all your fault. I hope everything's going okay. Please ask questions if you are stuck on anything. And I hope everything goes really well. I don't really want to edit this video right now, so I'm going to take a minute at the end to just draw you a little guy. There he is. Sometimes his eyeball comes off his head because that's funny to me. And we'll give him a little wrinkly forehead because he's always frustrated because life's frustrating. There's some hair. We'll make him bald because he lost all his hair. Here's his weird mouth. How about a little skinny neck? Because why not? He'll wear a collared shirt. And we won't finish him because, I don't know. Sometimes things are unfulfilling. All right, have a wonderful day.